In this video, I am going to tell about hydrocarbon. Okay, hydrocarbon. Hydrocarbon means hydrogen and carbon. You know, carbon and hydrogen has great affinity for each other, so they form bond, covalent bond between them. And the simplest form of hydrocarbon is the methane. Methane is widely used as fuel, okay, as a major component of biogas and compressed natural gas. This methane, CH4. CH4 is a widely used as a fuel, and it is one of the simplest hydrocarbon. you know Carbon is tetravalent because it has 4 electrons in the outermost shell. In order to achieve noble gas configuration, carbon shares these electrons with 4 hydrogen gas. Okay, and hydrogen gas shares one electron with each of the electrons, each of the 4 electrons of carbon. It is here. So here 4 covalent bonds are formed between carbon and hydrogen to make methane, CH4. Right? Just I am showing you, okay, on the pala card. Just you can see the formation of methane here now. Carbon shares 4 of its electrons with hydrogen, and hydrogen in turn serves 1 electron which each of the 4 electrons of carbon. Therefore, they forms covalent bond. Carbon and hydrogen forms 4 covalent bond. This is the electron dot structure, right? I am just showing you the bond, okay, structure. The bond structure will be like this. The bond structure will be like this. Carbon in the middle and hydrogen here now. So this is hydrogen. This is the bond structure. Bond structure of CH4. This is methane. Just you can see here now. See here. It is like this. See. It is like this. It is like this. Okay. So 4 electrons of carbon has been shared with 4 atoms of hydrogen to form methane. The bond formed by sharing of electrons is known as covalent bonds. So covalently bonded molecules are seen to have a strong bond within the molecules. Within the molecules they have a strong bond, but intermolecular forces are small. Therefore, they have low melting and boiling point. Right? Since the electrons are shared between atoms and no charged particles are formed, such covalent bonds are generally poor conductor of electricity. Right? Yeah. Now, allotropes of carbon. What are allotropes? The occurrence of an element in different forms is called the allotropes. The occurrence of an element in different forms, and they have the same physical, they may have different physical property but the same chemical property, and that is known as allotropes. Carbon has this graphite. Carbon has graphite, diamond as allotropes. Yeah. So carbon has different allotropes. So 2 important. One is the graphite, and other is the diamond one. Diamond. Okay, so these are diamond, is the purest form of carbon. Graphite, is a amorphous powder. It is, and it is used in as a lubricant um, in machines where hot parts are lubricated. Hot parts, very hot parts, because there the grease will not work. In very hot parts. Therefore, diamond is used as a lubricant in hot parts of the machine. Diamond can be synthesized by subjecting pure carbon to very high pressure and temperature. These synthetic diamonds are small but are otherwise indistinguishable from natural diamonds. Yeah. No, one is a full rain. Okay, full rains. FULLERENES, full rains form another class of carbon allotropes. Full rain forms another class of carbon allotropes. The first one to be identified was C60, okay, which has carbon atoms arranged in the shape of a football. Okay, so look at C60 fullerene is a combination of 60 carbon attached with each other. Okay, and that is known as fullerene. Yeah. So since this looked like a geodesic dome designed by US architect Buckminster Fullerene, the molecule was named, okay, Fullerene it is here now, Buckminster, okay, Fullerene, or simply Fullerene. It's okay. This Buckminster Fullerene was an architect, is right, and therefore it was um, designed, it was named as Fullerene. Uh, the nature of covalent bond enables carbon to form a large number of compounds. Okay, carbon compounds are very large in numbers, very large here. What is the reason? So the reason I am telling you, carbon has the unique property to form bonds with other atoms of carbon. Yes, carbon forms bonds with carbon. Sodium never forms bond with sodium. Potassium never forms bond with potassium. But carbon forms bonds with carbon, giving rise to a large number of molecules. Okay, and this property is called catenation. This property of carbon is known as catenation. These compounds may have long chain of carbon a long chain, branched chain, okay, of carbon, or even carbon atoms arranged in rings also. So carbon chains are a state chain. It may be state one, it may be a branched one, or it may be, okay, maybe a circular one in the ring shaped it is. Okay, so compounds of carbon which are linked by only single bond between the carbon atoms is called saturated compound. Yes, and compounds of carbon having double bond or triple bond are between them is known as unsaturated compounds. So, okay, the second reason for, okay, for so many, okay, compounds of carbon, first is the catenation, because carbon forms bonds with carbon. Second, since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element, means having valency 1. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds, okay, with specific properties which depend on the elements other than carbon present in the molecule. Yeah. So one reason for the formation of strong bonds by carbon is its small size. Yes. Carbon is a small size here, therefore the bond, covalent bond between carbon and carbon is very strong. It is. This enables the nucleus to hold on to the shared pairs of electrons strongly. The bond formed by elements having large atoms are much weaker. It is. Now look at the two characteristic features seen in carbon, and that is tetravalency and catenation, put together give rise to large number of compounds. So this is the answer why carbon has a large number of compounds. So the answer is that, okay, because of the catenation and because of this tetravalency, carbon has a very large number of compounds. So many have the same non-carbon atoms of group of atoms attached to other atom chains. Okay, urea from Friedrich Euler. Okay, this two. Okay, let us see this. Stop this one. Okay, now saturated and unsaturated hydrocarbon. So let me classify the carbon compounds. So one is the alkane, other is alkene, and third one is alkyne. Just I am showing you by writing. So, okay, one is alkane, alkene, and alkane. It is here. One is alkane, then other is alkene, and third one is alkyne. See the spelling here now. Look here, this is alkane, so all these three are common here now. See the spelling. This is ANE, this is ENE, and this is YNE, and this is ALK, is common to all these three. Okay, so this is alkane, alkene, and alkyne. So okay, this is alkane is saturated hydrocarbon, this is saturated hydrocarbon, this is saturated, and the other two are unsaturated. This is unsaturated. See here now. See, the first one is saturated hydrocarbon, and the second and third one is unsaturated hydrocarbon. Right now, so this is alkane, alkene, and alkyne. Yeah. Now, see, alkane. The simplest form of alkane is methane, CH4. This is the simplest form of alkane is methane. So that is saturated hydrocarbon, alkane. It is CH4. The simplest form is the CH4. It's okay. So this is the bond structure of alkane is like this. It is. So this is methane. This is methane. It's okay. So alkanes have single bond. Yes, they have the single bond. They don't have any double bond in between carbon atoms or with others. They have the single pattern. This is C. This is single bond they have. So this is the bond structure of methane, and they are single bond. Okay, they are singly bounded covalent bond. It is straight. Yeah. So let me tell you the way carbon are attached with each other. That is the state chain. So this is a state chain. Like this. Other is a branched chain. This can be a branched chain like this. Okay, see, this is number one is the exchange chain, and number two is branch chain, and number see, three types of chains. The first one is the state chain. This is a state chain. State chain, it is a state chain now. This is the branch chain. Look at the branches are here now. Look here. Okay, this is the branches now. This is the branches of this hydrocarbon. It's okay. This is the branches, and this is the ring structure of carbon. Okay, this is a ring structure. Yes, this is a ring structure. Carbon also form are combined together in the ring structure. It is like this. Yeah. So I told you the simplest form of hydrocarbon is the methane. Methane is the very simplest one. It is found in natural gases, methane, and so now I will show you how to find, okay, the first member of this alkane is methane. The alkane member, alkane, it is alkane. It is lot, three words ANE, ANE, alkane. So first is the methane. Methane, CH4. The methane, then it is, then propane, then butane, methane, it is methane, ethane it is. Second one is ethane. Then propane, and the fourth methane, ethane, propane, and then it is butane. Then it is pentane. Then it is hexane. The last three words is ANE, it is hexane. It is like this, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So this is the order, right? Yes, this is the order. Yeah, so this methane has one carbon atom, ethane has two carbon atom, propane has three carbon atom, butane has four carbon atom, pentane has five carbon atom, and this hexane has 14 hydrocarbon. It is like this. Just you can see here now. I have written the formula of methane like this. See, just see here. See, this is methane, first one. CH4. This is ethane. C2H6. C2 it is H6. Then next one is the propane. C3H. Okay, 8. It is 8. Then propane. Then after comes the butane. It is a butane, C4H10. This is butane. Then after what is this? This is pentane. And this is pentane. Then it is hexane. The last one is hexane. It is like this. So let me write the in next class I will explain you about the ethane, methane, ethane, propane, butane, etc. in details about their physical properties and the chemical properties. Dot structure, bond structure, it's like this it is. So this chemistry is very important. This is the compounds of carbon are studied under organic chemistry, you know very well. Okay, thank you very nice. Okay, thank you very much, and watch it and enjoy it.